Hello and welcome to my presentation about data types. The intended audience for this is students studying software development in Units 3 and 4 of the VCE. So, before we kick off, here is our learning intention that students can describe what information can be kept in specific data types, and there is the success criteria. So first of all, what data types do you know? There are data types that are not included in the VCE study design, but I would say the major ones are, and you might be looking at that image there and you might get an idea of some of them. I was going to say I thought some of them were misspelt, but they're not. So the ones that we're going to be concerned with today are an integer, which is a whole number, a float, which is a number with a value past the decimal point, a string, which is normally text, a character, which is a single character or a single letter, number, punctuation mark, space, a Boolean, which can be either true or false, and a thing called date time. So that's what we're going to be looking at today. So this is how the study design represents it, and we're covering all of that. So first of all, let's start off with what an integer is. An integer is a whole number without a decimal point. It can be positive, it can be negative, and it can also be zero. So my question to you is, what sorts of things could we store as an integer? And that image next to you, so actually some of those would be stored as integers, but I can see a lot of things in there that I'd actually store as a string. So how long can an integer be? I think that probably people who are not, well versed in computers probably think that you can just put any number you want in. If you've only got 8-bit with what we call signed, which means it can be either negative or positive, then, and an 8-bit is a byte, you can actually only go from minus 128 to plus 127. So and you might wonder, why isn't it plus 128? Because we actually need a value for the 0 in there. And so they've trimmed it off the top rather than the bottom. If it's unsigned, it's 0 to 255. So if we're not using it sort of underwater, if we're not using the less than 0 space, then we get to go higher. 16-bit is quite a lot more. It's 32,000 each way, or 65,000 in one direction. 32-bit, we're getting into some seriously big numbers. You've got 2 million and minus 2 million, or 4.2 million. If it's just there, but still there are plenty of things, situations particularly to do with money and probably maths generally, where you're going to go over 4 million. So 64-bit gives you, I don't even know how to say that, it's millions of millions. So that's it signed, and if it's unsigned, it's 18 something. I don't even know what that is. And my question to you before we move on is, what pattern do you notice between the ranges of the signed and unsigned? So I'll leave you to think about that. Next up is the floating point, or the float. Now these are decimal or floating point numbers, and obviously a float is going to be a floating point number. It comes in two parts, the mantissa or the significand, which represents the actual numerical value, and the exponent, which determines the decimal point position, and the sign, which is plus or minus. Now I'm actually going to go back to this because this isn't on the slide, but let's say I wanted to represent 3.14, then a 314 would be the mantissa, because they're the actual numbers involved, because a computer can store that pretty easily as an integer. And the exponent is how many places you're moving the decimal place. It's actually what the power of 10 is, but it works out to be how many spots you move it. So 3.14 is 314, and your exponent is 2. And it actually stores those in different places in memory. Whereas an integer can be written all together, you actually need to write a float in 2 places, which makes it slightly less efficient. So a string. A string is text or a sequence of characters in computer programming. In most programming languages, it's included in quotation marks and can be generally single or double, although there are languages where it matters. It can be letters, it can be numbers. You don't have to store numbers as an int or a float, or symbols, or just spaces. All of these things are are strings, and can be stored in strings. So when would you use a string for a number? Well, if you were just using an int and you were storing the postcode for this place in the Northern Territory, it would actually just save as 821. because that's actually the number. The 0 isn't mathematically meaningful. But it is the postcode. So you would store it that way to capture that leading 0. So that's one reason. Similarly, a mobile number. 0404, blah, 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 blah. You wouldn't get that leading 0. And if you wanted to put brackets and spaces in, because that might be meaningful, then you would also use a string for that. Just generally speaking, if you are not using the value mathematically, there seems to be a preference for expressing it as a string. I'm not 100% sure why. I think that an integer is pretty efficient memory-wise, but in the examples I've seen, there seems to be a preference. If you're not using it mathematically, store it as a string. Okay. Now, I don't seem to be leaping forward here. Let's have a quick look. Oh, there we go. A character. This is a single text symbol. It uses 1 byte or 8 bits of memory, so it's very efficient, and it can store letters, numbers, punctuation marks, special symbols, and it can even be a space. Represents a simple Unicode or ASCII character. If you don't know what Unicode and ASCII is, that's a very valuable idea to have and is worth looking up. And it can be enclosed in single quotes. Not all languages use a character data type. And it supports arithmetic and comparison things. So if you're putting numbers in there, you can say, is this greater than this? It will work with that when it contains maths. I think our last one, actually our second last one, is Boolean. This is my least favourite of these graphics, but a Boolean can only be true or false. In some languages it's spelt with a capital T and a capital F, and in others it isn't. And I actually never remember which one it is. That's the beauty of using an IDE, in that when you type it, it'll either change colour or it won't. I wish I could tell you a rule. So, it can be true, it can be false. Can't be maybe. It represents binary states. Often Booleans are used in conditional logic and control structures. So you can actually, if you write a selection statement, if temp is greater than 18, you're in fact creating a Boolean condition. That will either resolve to be true or false. It can't be anything else but that. And then you're working with that logic. So they're both a data type, and also, I don't even know how to describe it, kind of a fundamental building block of programming that you are expressing things that can be either represent truth or false. And a question for you is, what information could we store with a Boolean value? So, last one that's in the study design is date time. Date time uses this format: years, months, and days. Then that second T there after the days is actually fixed in it. That doesn't turn into a number, and after that it stands for time, and after that is hour, minute, second. So you can represent any time you want with this. I actually don't know. I haven't checked whether it will work with negative years. If you were to represent, 100 BC. I know there's another name for BC these days. I can't remember what it is, but off the top of my head. It stores both the date and the time, and it supports complex time-related operations. So you can, with libraries and so forth, you can say how many seconds are there between this time and this time. My personal preference is for epoch time, which is just the number of seconds since the 1st of January 1970, but this is in the study design, so it's worth knowing about. And it handles time zones and daylight savings consideration, although I wouldn't like to explain to you how, but apparently it does. And I said you can do calculations with it. So there's an example of it down the bottom. That is 7 a.m. Christmas Day. I think I actually meant to put that up and get you to tell what it was, and maybe you can tell what the next one is. Okay, so that's it for data types. I think it's worth understanding that you can cast one data type to another. So some of them can be swapped, can be turned from one form into another. Some can't. Some things will fail to be cast, but some things certainly can be cast. So there is implicit casting, which is automatic conversion, which the program does itself, and it says when there's no risk of data loss, converting an integer into a float. So, you'd have 1 and it would turn it into 1.0. And then there is explicit casting, and I'm going to show you an example of that in a minute, which is manual conversion, and it's where the program is doing it, and it is possible to have some data loss in that, although I don't think that's in my example. So, speaking of examples, let's go and have a look at these. I've got a few set up for you, and I'll try and move through them quickly. First of all, I've said name is Mr. O'Mara, and that's in talking marks. It's also non-mathematical, and it's longer than one character, so when we run that, it identifies that is a string. So, no surprises there. With Python, you don't actually have to tell it what the data type is. It will automatically type it. So this one here, 55, will be automatically typed as an integer. Likewise, 96.6 will be automatically typed as a float. This is a Boolean and is automatically typed. You'll notice there's no talking marks around that. If I were to put talking marks around that, even though it is the word true, I'm now actually making it, I'm not tricking it, I'm directing it to regard that as a string. But without the talking marks, it will recognize it as a Boolean. Date time, Python doesn't seem to natively understand it, but the beauty of Python is that with the right library, it'll do pretty much anything you want. In this particular example, it's printing it, and it isn't quite in the format that we're expecting. There's no T there, and there's some decimal values after the seconds. So it's not an exact match for the date time standard, but I bet there's a way of shoehorning that in. So up here, I've got age as 55, and I'm going to try and cast it as an integer. So when I do that, you'll see that the program actually fails. That it goes into an error state. So it can't do that casting. You can't cast from everything to everything. So here I'm going to say while true, and truth is always true, I'm going to try and collect an integer from an input of entering your age. So I'm going to make this succeed, and then I'm going to make it fail. So 55, and that succeeded because it didn't break. And then I'm going to type something in, and you'll see that it broke. So when the user is well behaved, this is a perfectly good construction. When they don't understand it or they put in the wrong value, you'll break your program, and generally speaking, we want our programs to be robust, which means that they handle errors gracefully, and that's not handling it gracefully. Let's try and handle it gracefully here. While true, and by the way, to me this seems like a lot of effort to go through to get an integer, but there you have it. We're going to try to collect it as an int. If that fails, we're going to print a message, and if it succeeds, then we're going to say your age is this, and actually we're going to break out of the loop. So let's have a crack at this. So first of all, I'm going to try and fail with a float. There we go. So I'm still in the loop, and it's saying please enter a whole number. I'm going to type some text. Please enter a whole number. I'm going to put an integer, and we're going to succeed. It's going to identify that as an integer, and then we're going to be released from the loop. So hopefully that makes a bit more sense of casting. You have two types of languages. You have strongly typed, of which Python is strongly typed. It won't kind of recognize the context and say, okay, I will treat this way. And you have weakly typed. Now, there's obviously hundreds of languages. I'm just talking about the most common ones, and particularly the ones I use in my classes. PHP is weakly typed, and I love it for that. And JavaScript, it says is weakly typed. I don't think it's as weakly typed as PHP. I more often get myself into trouble in JavaScript. So why do we have those data types at all? Well, there's a few reasons. Part of it's just historical. It's been built into older languages, and so when people have created newer languages, they have, rather than having them completely weakly typed, they've said, oh no, this is the sort of thing that programmers want to have awareness and control over. And I would say as a program in 2025, you do want to have awareness and control. You should never have a variable in your program and you're like, I just don't know what data type that would be. Even if it's in a loosely or weakly typed environment, you should know what it is. And also, they're just written differently to memory. You know, memory is stored as ones and zeros, and, you know, all ones and zeros kind of look the same. So it's a way of saying, hey, I'm putting this in the box, and this is a label on the box saying, hey, when you unpack this, read this as this data type. So it does translate into them being stored differently. I saw something, and I probably should have looked this up, where it shows you a whole lot of ones and zeros and says, if you read these as an integer, this is what it'd be. If you read this as a string, this is what this would be. Because it's basically a way of decoding it and saying, hey, that's how we write that. So let's have a look at what we know. So I'm basically looking for you to identify what's the data type here. A program needs to store a student's age in years. An online shopping system needs to track whether a customer has agreed to the terms and conditions. Yes or no? Bit of a giveaway. A weather application needs to store the temperature reading of 23.7 degrees Celsius. A school database needs to store a student's full name, such as Emily Chen. And a game needs to keep track of a player score, which can only be whole numbers. And a banking app needs to store an account balance that includes cents. So, let's have a look at this. That's obviously an integer. Your age is, you know, unless you're Adrian Mole, age whatever he was. This is Boolean. It's a yes or no answer. This has a number after the decimal point, so that's a float. That's a string because it's non-numerical and it's more than one character. This is an integer because it says it can only be whole numbers. And this, I actually think you could argue this two ways. I think the best answer is to say that it's a float. I think you could argue that you could store this as cents and you could just render it on the screen as that many cents. But I think the most common answer would be a float. So that brings us to the end of this presentation, and I hope that's been useful to you.